In this video, we'll solve some practice problems in computing limits, and let's begin with the limit of 8 minus 3x plus 12x squared as x approaches 2. Now, the easiest thing to do is to just plug in the value of our c, or the value that we are approaching. So we have here 8 minus 3 times 2 plus 12 times 2 squared. Simplifying this one, we get 8. This is negative 6, so we have minus 6 plus 12 times 4. We have to simplify first the term with exponent. Now, simplifying this further, we get 8 minus 6 plus 48. Now, this is equal to 50. Therefore, the limit of 8 minus 3x plus 12x squared as x approaches 2 is equal to 50. This is our final answer. Now let's move on to another problem, and let's try to solve for the limit of 6 plus 4t over t squared plus 1 as t approaches negative 3. So let's plug in negative 3 to the function. This gives us 6 plus 4 times negative 3 all over negative 3 squared plus 1. Now simplifying this one, we get 6. This is negative 12. So minus 12 all over negative 3 squared is positive 9 plus 1. So simplifying further, we get negative 6 over 10. Now to express this one in its lowest term, we divide both our numerator and denominator with 2. So we get negative 3 and we get 5 in the denominator. Therefore, the limit of 6 plus 4t all over t squared plus 1 as t approaches negative 3 is equal to negative 3/5. This is our final answer. Now let's move on to another problem, and let's have the limit of x squared minus 25 all over x squared plus 2x minus 15 as x approaches negative 5. Now, if we plug in negative 5 to the function, our function will become indeterminate since our numerator and denominator will become 0. But that does not mean that the limit does not exist. What we need to do is to simplify the function first before we plug in negative 5. So let's try to factor out both our numerator and our denominator. Our numerator's factors are x plus 5 and x minus 5, since this is just the difference of two squares. Now for our denominator, we have x plus 5 and x minus 3. Now since we have x plus 5 in our numerator and our denominator, we can just cancel them out. So what remains is x minus 5 and x minus 3. So if we substitute now negative 5 to the function or to the value of x, we get negative 5 minus 5 all over negative 5 minus 3. And this is equal to negative 10 over negative 8. Simplifying this one to its simplest form, we get positive 5 over 4. Therefore, the limit of x squared minus 25 all over x squared plus 2x minus 15 as x approaches negative 5 is equal to positive 5 over 4. And this is our final answer. Now let's move on to another problem. We have the limit of 2z squared minus 17z plus 8 all over 8 minus z. as z approaches 8. Now if we plug in 8 to the function, this will become indeterminate again because the numerator and denominator will become 0. But what we can do is to simplify this function by factoring out our numerator and find a term that we can cancel out. So factoring our numerator, we get 2z minus 1 and z minus 8 all over 8 minus z. Now, can we cancel out z minus 8 and 8 minus z? We cannot cancel them out since they're not in the same form. So we have to rewrite one of them. So by rearranging the terms, we get the factors for our numerator 2z minus 1 and z minus 8. Our denominator will now become negative z plus 8. When you rewrite functions or you rewrite this one, you have to carry its sign. So this becomes negative z and positive 8. Now still we cannot cancel them out since this is positive z and this is negative z, this is negative 8 and this is positive 8. So we can pull out negative 1 in our denominator so we can cancel z minus 8. So by pulling out negative 1 in our denominator, we get 2z in the numerator minus 1 z minus 8 all over negative 1 times z minus 8. Now, since we already have the same terms in our numerator and denominator, we can cancel them out. So, what remains is 2z minus 1 divided by negative 1. So, if we plug in 8, we get 2 times 8 minus 1 over negative 1. This is 16 minus 1, 15 over negative 1. Therefore, the limit of 2z squared minus 17z plus 8 all over 8 minus z as z approaches 8 is equal to negative 15. And this is our final answer. Now let's have another problem and let's solve for the limit of y squared minus 4y minus 21 all over 3y squared minus 17y minus 28 as y approaches 7. Now if we plug in 7 to the function, this will become indeterminate. This is 0 over 0, but that doesn't mean that the limit does not exist. So we have to simplify this one. So by simplifying this one, when we factor out our numerator and denominator, we get y minus 7 and y plus 3 as factors of our numerator, and 3y minus or 3y plus 4 and y minus 7 as the factors of our denominator. Now, since we have the same terms here, y minus 7, we can cancel them out. What remains is y plus 3 and 3y plus 4. Now, if we plug in 7 to the function, this will become 7 plus 3 and 3 times 7 plus 4. Now, simplifying this one, we get 10 over 25. And simplifying this further, we get 2 over 5. We just divided both our numerator and denominator by 5. Therefore, the limit of y squared minus 4y minus 21 all over 3y squared minus 17y minus 28 as y approaches 7 is equal to positive 2 over 5. And this is our final answer. Now let's move on to our last example. We have the limit of 6 plus h squared minus 36 all over h as h approaches 0. Now we plug in 0 here, this will become 0 over 0, still indeterminate. But we can actually simplify this one. So what we need to do is to simplify this one first before we substitute 0 to the function. By simplifying this one, we will have 36 plus 12h plus h squared minus 36 all over h. Now we have 36 here and another 36, so cancel them out. So we get 12h plus h squared over h. Now by common monomial factoring, we have h times 12 plus h all over h. Since we have h in the denominator, we can cancel out h. So what remains is 12 plus h. Now if we plug in 0 to h, this will become 12 plus 0, or simply 12. Therefore, the limit of 6 plus h squared minus 36 all over h as h approaches 0 is equal to 12. Now this is our final answer.